So thanks everyone for being present to this webinar. Today we have the honor to welcome Dr. Bubacarr Bah, who is a data scientist and professor assistant at the MRC in Gambia. And he's a member of this project, AFRICAI-RI. So today he will talk about the AFRICAI-RI tools, data infrastructure, and how to get started. Thanks. Bubacarr, you have the floor.
Thank you very much. Can everyone hear me?
Yes, very clear.
Yes, thank you. Yeah, I thank Mamadou for inviting me to give this talk. Mamadou is leading the training working group, and this webinars has been organized under the training working group for those who are outside this project. And Mamadou, what I realized that this is very similar to the title is almost similar to the first talk by Lydia. But I try to make it as different as possible. Yes.
Okay.
Yes, thank you. So let's move. Allows me. So that was the outline of my talk. I'll give a quick intro, then discuss the AFRICAI-RI ecosystem, our data infrastructure and federated architecture, tools and services, governance issues, and then some tips or guides around getting started and our vision and call to action. Okay, so our claim was that Africa is facing a critical gap in medical image diagnosis, but then given the current advances in AI diagnostics, we see a great potential in using AI-driven solutions. Hence, AFRICAI-RI was established to harness this opportunity, and we wanted to build a shared infrastructure which can accelerate discovery while respecting data sovereignty and local governance. And what is this gap? Okay, we think these gaps are created by critical barriers that are barriers to advancing medical imaging across Africa. And AFRICAI-RI has the potential Africa has a medical imaging potential, which is constrained both structurally, technically, and ethnically. What we mean by the structures we have are not designed to use AI, but also we don't have the technical capacity, both in terms of infrastructure and in capacity of people that can handle the technology that is needed. But also there are ethical issues that we need to take into consideration. And as a result, these barriers limit our ability to collaborate effectively. They limit research capacity, and they risk compromising patient data sovereignty. Looking at the current landscape, we think imaging data sets are scattered across countries and institutions, which is preventing this coordinated research, limiting the ability to scale robust AI model development. But also, as I hinted earlier, there's a big capacity gap in imaging AI research expertise, in tools, and in computational resources across the country, which actually slows the development and adoption of AI solutions. There is limited access to infrastructure, both hardware and software, in terms of compute resources, in terms of data pipelines, standardized workflows within Africa. And then added to that, there is the issue of data sovereignty and privacy concerns that are being raised every day now, which either makes people just to keep to their data being in silos because they don't know how, they don't want to lose sovereignty of this data. They don't know if their privacy concerns have been addressed adequately. So all that are issues that are hindering the scaling of AI solutions in this space. So this motivated the establishment of the AFRICAI-RI ecosystem, or the AFRICAI-RI platform project. And the key things in that project is privacy by design, we want to respect sovereignty, and we want to enable innovation. Okay. So the platform will be secure, ethical, and it will boost collaborative research that powers Africa's research and for Africans, led by Africans and for Africans. That seems like a political statement, but anyway, that's what we want. So the AFRICAI-RI would enable a Pan-African medical imaging research through a federated sensitive patient data securely within each country's borders. No cross-border data is done, sharing is done. AI models are the ones that would travel to the data, but not the other way around. Okay. So in a way, this preserves sovereignty, upholds patient privacy, and ensures compliance with local legal and regulations. So essentially, yeah, we say the key things is data stays local. So only approved AI model parameters are exchanged. And this federated AI fosters innovation as a result, because now we have access to more data. Yeah, and the setting up this would involve building capacity in communities that would be able to use these solutions. So what is the AFRICAI-RI? This is a Pan-African research infrastructure for collaborative biomedical imaging in AI and AI in respiratory care. So the platform would be something like what you would see in that picture, where you can access it online and you can be added so each of the research partners is considered a node. So you can, if you want to join, you will be added as a node if you satisfy the qualities, the criteria for a node. You can use the platform to curate data, you can submit your data, you can do searching on this catalog, you can access data, you can process the data, but in addition also you can build, you can play with our AI model that we build, but you can try to build your own federated model. So this would be an African infrastructure for medical imaging research, connecting institutions continent-wide through a secure federated model. It is designed to address the unique challenges that we mentioned earlier. So a multi-country collaboration, we have these countries that are part of the consortium on the Africa side, the Senegal, Gambia, one with the Black Star, Ghana, Nigeria, Gabon, DRC, Uganda, Ethiopia, Malawi, and Mozambique. Now I got everybody right this time. So essentially, we build this trustworthy, ethical AI platform that would have real impact on health care across Africa. So the consortium partners are listed in more detail here, and instead of just the countries, we have the members like CHISM. This is in Mozambique, Delph Imaging, Ghana. SCAMEL is in Gabon. This is JIMA in Ethiopia. IDRC, I think, is Uganda. Correct me if I'm wrong, Momodu. That's NIMER is in Nigeria. UIDT is Senegal. Kamuzu is in Malawi. And then the unit of Kinshasa, of course, is in DRC. And we have the MRCG unit here in the Gambia. So those are the 10 African partners I mentioned, but we are in partnership with European partners. This was an EU-funded project. So we have Barcelona, which is the coordinating body, coordinating institution, but we have Barcelona, obviously, is in Spain. Erasmus MC is in Holland. Ford is in Greece, and ISIS Global is in Barcelona also. So our objectives were to have a new African imaging dataset for global research, with validated federated AI models across diverse sub-Saharan African data, and improve diagnostic accuracy and equity. What are the core components of AFRICAI-RI? AFRICAI-RI is built on 4 interconnected components that together create a robust, let me just minimize this, a robust, trustworthy, and scalable Pan-African research infrastructure. Each pillar addresses a critical dimension, enabling collaborative AI research while respecting data sovereignty and promoting African-led innovation. And the components that make up this, make this 4 are the data infrastructure, AI tools and validation, data operations and governance, and capacity building. In terms of data infrastructure, we want federated data access, enabling secure cross-institutional collaboration without moving sensitive patient data across borders. While the AI tools and validations will be frameworks for developing, testing, and validating AI models, ensuring accuracy, fairness, and clinical relevance across African populations. And the data operations and governance gives us robust governance frameworks and data operations, ensuring ethical oversight, compliance, and responsible data stewardship. And to top it up, or to kind of, for sustainability reasons, we want to do capacity building and capacity and community building. And in that way, we come up with training programs and community engagement activities, growing African expertise and leadership in medical imaging AI research. And example use cases, for this phase of the project, we were focusing on 2, which is ultrasound, TB and pneumonia. And we will be using X-rays and an ultrasound. So point of care ultrasound and chest X-rays to diagnose TB, both in adult and in children, but pneumonia specifically for children. And using ultrasound for TB also, this is a new area, but we want to give it a try. Currently, we have retrospective data and we hope to collect prospective data. The prospective data will be little, but part of the prospective data will be collecting ultrasound images to diagnose TB. We hope to contribute to the growth of this area. It's new, it's not well mature. So hopefully some of the research we will be doing would also contribute to growing that area. But yeah, the plan is not to limit just only to TB and pneumonia, but to expand beyond these diseases and these modalities for imaging. Okay. So essentially, an AI-powered imaging application addressing Africa's most pressing health challenges across multiple modalities and settings would be our target. In terms of data infrastructure and the federated architecture, let's first look at the federated architecture. So the federated architecture in Africa, in the AFRICAI-RI federated architecture, medical imaging data remains securely stored within local institutions and never crosses national borders, like we mentioned earlier. AI models are distributed each site where training occurs on site using local data. Only approved anonymized model parameters, never raw patient data, are exchanged between sites and central coordinating layers. And the central coordinating layer. This design ensures full data sovereignty while enabling powerful collaborative AI research across the continent. So again, the main message is data stays within local institutions at all times, preserving patient privacy and national data sovereignty throughout the research process, and only encrypted model parameters are exchanged. In that way, you enable continent-wide AI collaboration without moving sensitive data. So I thought I could just give a quick crash course on what federated learning is about. So this is coming from machine learning. So federated learning is distributed machine learning, where you build these models in a way that the models go to the data. So if you look at the diagram there, you have a central server where you think of as if you're currently doing some machine learning, you're building a model, you're running it on your server, or maybe you're running it on Google Colab. So this is what happens. It's just one server or one computer you're using to compute one model you are using, to be precise. You might use multiple computers, especially if you're using cloud resources. But then when you're building it locally, you have one model you're concentrating on, and all the data is in one location. This is the centralized model. In the federated model, the data is in different locations. The model is being built as one model, but it wants to use these different data. So what happens is you have the global model, which is this one big model you're trying to build, and you would start it at your central location, like here is a central server, and then you will share this model with different sites that have data. Here you have, I don't know if you can see my pointer, you have this site here, that site there, that site there, and that site there, that would get this model, and they will train the model. The model will run on their local data a couple of times. We call it a couple of epochs. And then those model parameters, what are the weights of the model at that point, are sent back to the central server. Not the data, just the model. That's what I was talking about, model parameters. The weights of the models, okay, are sent back to the local server. And some way you find a way of combining these to update your models, your global models weights. Okay, this is what is called aggregation. You try to aggregate them, and then, oops, I'm going too fast. Yes. Okay, and then you would test this with this new update. You test how good your model is, and then if you still think it's not good enough, you reshare this new model that you have updated from earlier trainings back to this nodes, these local nodes, and they do more further training again. And the weights would change, obviously, and those weights, after a while, are also collected back and aggregated. The model is tested again to see its performance. Hopefully, while you do this, the performance is improving. At some point, you're happy with this model. It's become your global model that everyone can use, but it's trained on data from different places, while those data were never brought together in one location. That's the whole point about federated learning. Okay, so this is what we want to do for AFRICAI-RI. We have our different countries have different images, for instance. So we want to do this federated model that will be sent to these different locations and trained locally and globally aggregated. Probably we should have updated the diagram. So MRCG would be the central node where we would have the global model updated. So this should have been located here in the center.
Yeah,
but anyway,
yeah.
you know the idea, okay?
Yeah.
Okay. So the architecture we're still working on it. We are working. We have the different working groups, and one of the working groups is the infrastructure working group. And we developed a draft architecture here where we would have. So each of our members is a regional node, and a regional node then will have a clinical site, either within the institution or outside. Like for instance, at MRC, we have a clinical site where this is collected within the institution. But places like the University of Chess, for instance, UIDT, where Mamadou is, they collaborate with a clinical site which is outside the university. So they would have the infrastructure that is needed for the clinical part, but then the institution itself will have what is called the XNAT. That's where all the data will be stored, all the images will be stored if they come from the clinical side, including also the clinical data. We would also collect clinical data. This is necessary for the diagnosis. And then we have the central node, which is MRC, where we would also host locally our local data on our XNAT. But then we should be able to now do this model aggregation. For some reason this is moving. This model aggregation, and the platform that would be used for this is called FEDA. Okay, this is one of the platforms for manipulating or implementing federated learning modeling. Okay, so we will have one sitting with us. Each of the nodes will have one to help them do the local training. But with this FEDA, we are able to move weights back and forth to the global model. Okay. UIB have what is called the orchestrator. That's where you can actually launch the FEDA instance. You can start your model. So the whole central Actually, I will discuss in the next slide. But essentially, this is the draft setup. Users, we would have users log into the platform. The platform will be part of a local platform we have at MRC, which is called HDRWA, which I'll talk about a bit later. And then you can access the platform data like the catalog and so on. Researchers can, if they want to, researchers, especially AI modelers, would need to log into the orchestrator to have access to the orchestrator to be able to start model training, which is provided currently through UB. Okay, this is going back, should be going forward. So at the local side, therefore, what we will have is to maintain each local site, to maintain its dedicated infrastructure stack. And one of the infrastructure would be, like I said, it could have the imaging data, it could have the clinical data, all that should be available, and that should be uploaded into an XNAT that will hold the imaging. Somehow this is connected to the clinical data, but also we have to do some quality checks and so on. So therefore there is a tool that does that. So all this combined. So essentially, these will be like 4 different components. You have the imaging repository that I talked about. You have a secured data storage system, you have clinical databases, and you have local compute to be able to run your models locally. So this will be hosted locally also for each of the members, okay? And then to make things work, you have this federated layer, okay? Which is sometimes difficult to represent in a diagram, but think of it as just some middleware enabling this secure distributed coordination across the African institutions, okay? So it would include this federated learning framework like the FEDER that I talked about, with coordinated distributed AI modeling across multiple sites, aggregating model updates without exposing raw patient data. It would have to go through some authentication and authorization, of course, for security purposes, which manages user identities and access permissions. We would have a secure communication channels. The communication between the channels or the different sites would be in a secure way. The data will be encrypted, and that would safeguard all inter-site transmissions. We would have orchestration services. I mentioned the orchestrator would be based at UB, which will monitor and manage federated workflows in real time, ensuring smooth operations and compliance across all consortium partner institutions. So the diagram was something I adapted from Lydia's talk earlier in this seminar, where this is actually what happens. This is the federated setup for our project, and MRC you can see as the core as the central node here. So the central nodes should provide some services, and I would say the central node here is MRC, but some component of the central node which will still be with UB, which is the orchestration. But the central node would provide or form the backbone for the AFRICAI-RI coordination layer, providing shared tools and systems that connect distributed local sites in a coherent, governed research network. These services ensure that researchers can cover data requests, operate within secure and well-managed environments. And in a sense, what are the main components? There would be a metadata catalog. So that's what we try to represent here as the AFRICAI-RI catalog, which would hold metadata. Yeah, but monitoring and orchestration, like I said, the orchestration. So if you just consider all this top layer as the central services layer, you would have the orchestrator hosted by UB, okay? Access management will be part of it. You have a centralized coordination, okay? And I guess those are obvious. In the metadata catalog, you will index datasets and resources across all participating institutions, enabling researchers to discover and identify relevant images from their studies. But for monitoring and orchestration, we ensure smooth operation across the federated network, tracking system health, monitoring training workflows, and infrastructure performance continent-wide. Then data access management, we should control permissions, and we govern who access which data sets. enforcing data governance policies, and supporting the data access committee decisions. Okay, I'll talk about data access committee in a while. Okay, and there's a centralized coordination which will bind together local sites and federation layers, providing a unified oversight and ensuring all components operate in an aligned way. So the key principles of this setup is that all data satisfy these three key points here, or these three key principles: fair data practice, secure by design, and data sovereignty. When we talk about fair, I think the data is findable, accessible, identifiable, and reproducible. Interpretable. The I is interpretable.
Operability.
Yeah.
Interoperability.
So interoperability, yes. Findability, accessibility, interoperability, and reusability, okay? So that's fair. What does fair stand for? So we make sure what the data we are generating satisfy those conditions, which enables consistent, high quality research across all institutions. And with secure by design, we mean every component of the AFRICAI-RI is built with robust privacy and secure measures from the ground up, ensuring patient data is protected at every layer. And data sovereignty, of course, like I mean, is African nations retain full ownership and control of their data. No cross-border data movement is required in this setup. So what are the tools and services that this platform offers? So AFRICAI-RI provides a comprehensive toolkit for preparing medical imaging data for federated AI research, but these tools ensure that data sets are properly de-identified, quality controlled, and standardized before being registered in the catalog, therefore enabling safe, ethical, and interpretable research across the African continent. These curation principles the toolkit itself have 4 key components that we require it to have: de-identification workflows, it has quality control procedures, it has metadata standardization, and a federated dataset preparation. So the curation pipelines are designed to respect data sovereignty. The de-identification and quality controls automate workflows that remove patient identifiers from DICOM images and records. For metadata standardization and federated prep, this will give us consented metadata schemas that ensures data sets are described uniformly across sites. And we already identify a tool. This is actually the tool that has been developed by one of our partners, EMC, Erasmus. The guys in Holland developed this Lite DICOM anonymizer, which has very nice features like Dockerized pipeline, ORC integration, and flexible I/O. I'm not going into detail for probably the non-technical people in the audience, but essentially it does what those qualities I mentioned earlier. You know, it could do study ID management, dual mode operate, it has a dual mode operation, and it can do data restructuring. In terms of the other tool, and in addition to the de-anonymization tool, is this catalog. We mentioned it earlier. Here now we go a bit more detail. So again, the AFRICAI-RI data catalog provides a unified discovery platform indexing metadata from imaging data sets held at institutions across the consortium. Researchers can then search, filter, and identify data sets relevant to their studies without data leaving its source. So with this catalog, you can cite and the metadata gives you information that you need to see if this is the data that you need to access. Then you will have to follow procedure to get access to this data, okay? So the catalog supports transparency, reproducibility, and collaboration by making dataset descriptors, including mortality, size, demographic, and annotations, you know, and even some other clinical features that we can describe without exposing information about patients. It has these two. It has these two features. Can the admin mute that person? So the key features of our catalog will be it would have the searchable metadata, but also it will have data entries which includes stuff that I mentioned earlier, like modality, types, patient demographic, and so on. And already also one of our collaborators have developed one of these catalogs that we will adapt. There's a central catalog for dataset descriptions. It is using the Molginis technology. And the data model is based on the health DCAT AP, data catalog vocabulary for health, and a standardized data set, metadata. And of course, the good thing is then, because this is built by a consortium in Europe, this will make interoperability with European data sets and data infrastructures easy for us. So it is therefore, whatever we generate will be compliant to international standards like the EHDS. It will improve data set discovery, governance, and fair compliance. I've defined fair earlier. And this medical imaging data catalog will be hosted on our ADRWA platform. This was established through the Wanetam project, which was a network on TB, AIDS, and malaria in West Africa. It includes about 25 research institutions in 10 different countries in West Africa, both Anglophone, Francophone, and Lusophone. And the platform focuses on data management and data sharing. And this addition of the AFRICAI platform will be a big boost for this platform. And it will also be building the AFRICAI platform will be building on structures that are already built for the ADRWA, like governance structures and so on. So the other tool is the secure data. So we talked about the, if I remember right, so we were listing the tools. There was the catalog, and before the catalog, what did I talk about? The data toolkit, then the catalog, and then the, now I'm talking about the secure data access manager. Okay, access should be governed by data sharing agreements, ethics approvals, and AFRICAI governance policies that ensures sovereignty and compliance. So we will expect this to be put in place. We have not started setting this up, but this is part of our plans. It would give us control and transparent and auditable access to sensitive medical imaging data sets across the network. And the procedures or the instruments that would support this would be formal request workflows, where researchers will submit structured data access requests specifying intended use, scope, and ethical approvals. Each request is logged and tracked through a transparent review pipeline, ensuring accountability at every stage of the process. And the data access committees, which we are working currently hard to set up, we have this is actually one of the task or milestone for us here at MRC. We are setting this up. We've got representatives for the committee that being compiled currently. I think only one member is here to send a representative on that committee. And then the goal will be adapting the data access committee guidelines that were set up for ADRWA now for this committee to work with. Okay. Then there is, of course, for this for the secure data access, you need to have user authentication and permission. Something like a multi-factor authentication and role-based access control. And so only authorized users can access approved data sets with time-limited permissions and full audit trails. So this is hoped to be set up. And then I want to talk about AI development environment next. So the AFRICAI AI development environment will provide researchers with powerful GPU-enabled compute resources capable of handling demanding AI workflows. So it will be a GPU-enabled infrastructure supporting federated model training, benchmark data sets, and reproducible research workflows across the network. And the platform, the development, AI development environment would provide researchers with these powerful GPU computes. Therefore, it will enable federated model training capabilities that allow algorithms to be trained across distributed sites without moving sensitive data. But also we want to be able to use curated data sets that enable consistent performance evaluation across institutions, reproducible workflows I mentioned, and so transparency and scientific integrity, supporting rigorous and trustworthy AI across the continent. So those three things would be the key features of the AI development environment. There's this federated model training capabilities. It would have this curated benchmark data sets and reproducible workflows. And we also wanted to have a trustworthy AI toolkit, because whatever we build, we want at the end of the day for clinicians to be happy, to be confident, or to use, not to call it clinicians and patients also to trust the output of our platform. Okay, the tools that are based on our platform. So we would want to come up with a trustworthy AI toolkit that provides researchers and institutions with a comprehensive suite of tools to validate, monitor, and ensure the fairness and transparency of AI models developed within the federated infrastructure. This way, we will build confidence in AI-driven medical imaging across the continent. And this trustworthy AI toolkit would therefore have also these 4 features: model validation frameworks, performance monitoring, bias assessment for fairness, explainability, and transparency. In terms of model validation frameworks, we want to be able to assess accuracy regularly, its robustness, generalizability of the models across diverse African populations and imaging contexts. But also in the performance monitoring, we want to continuously track the performance of the model over time to see if there is drift, degeneration, or inconsistency in the deployed AI system. Of course, bias is an issue. We will try to build models that are less biased, because we're using now African data. Therefore, we hope to minimize the bias, but still we will have to continuously be assessing this bias. There'll be systematic evaluation of model output across demographic groups, imaging equipment types, and clinical settings to ensure equitable AI performance for all patients. And this will be continuously done once in a while, to reevaluate the bias or reassess the biases of our models. Of course, we want to build in explainability and transparency. This will boost also trust for our tools, so tools that ensure that surface model reasoning and decision pathways, enabling clinicians and researchers to trust and interpret AI outputs responsibly, will also be taken into account. So those were the issues around tools and services of the platform. Now I want to talk about governance, ethics, and data access. Why governance matters? Governance is not a bureaucratic formality, as it's usually said. It is the backbone for us, it is the backbone of the AFRICAI-RI mission. By establishing clear rules, oversight bodies, and accountability mechanisms, governance ensures that AI research remains aligned with patients' rights, national laws, ethical standards. It enables institutions across diverse countries to collaborate with confidence, knowing that shared frameworks protect all parties involved. Okay. Therefore, we want to be able to ensure ethical AI development, build trust, support cross-border collaboration, and protect data sovereignty. In ensuring ethical AI development, aligns with patient confidentiality and human rights principles across all member institutions, while building trust amongst researchers, institutions, patients, and policymakers by demonstrating accountability and transparency. Of course, supporting cross-border collaboration is key, which will therefore take into account, which will be within legal and regulatory frameworks, enabling multi-country research participation, where we would respect regulations and legal requirements within each of these countries. Okay. And of course, data is not living, so therefore we protect data sovereignty by ensuring each nation retains control of its own data and how it chooses it. What is the governance structure we have in mind? The governance structure for AFRICAI-RI would ensure ethical, accountable, and legally sound AI research across the continent, and therefore would have key instruments like the Data Access Committee. It oversees all access requests. It would have legal requirements that we all have to satisfy as both users and consortium members, and ethics oversight. We started with ethical approvals for each of our consortium members to seek their ethical reviews and approvals. And we have also site responsibilities. Each institution has a responsibility over its own data governance and maintaining compliance with national regulations locally. Researchers within the consortium or researchers wanting to use the platform also have responsibilities. All researchers across the AFRICAI-RI infrastructure must uphold the highest standards of ethical conduct, responsible AI development, and data governance. These responsibilities ensures the integrity of the research ecosystem, protect patients' privacy, and maintain the trust of contributing institutions and communities across the continent. You want to obtain and maintain valid ethical approvals, like I mentioned earlier. We want to follow responsible AI principles, including fairness, transparency, and accountability. We respect all data sharing agreements and governance policies and ensure output protects patient confidentiality. I don't know if I'm going too fast. I'm asking this question a bit late, supposedly. So getting started, I had a few tips or a few things that I thought of for different parties. For data contributing institutions, the platform, you need to access, have access to the platform, which will be through HDRWA. And I mentioned the different things you can do. But we would officially do an open call. We're setting up, which was part of the project plan, and we're just setting up the open calls committee for people who were not part of the initial consortium can still join us, either as data contributors, because in that way you can contribute your data. And for now, the plan is your data can be hosted by one of the nodes, and the central node MRCs has been identified to be able to do that for you, especially if you don't have the infrastructure to host your data. So the open calls committee has been set up, and it would work with MRC to see that if new members want to join and they don't have, because we may not have funding for them to buy equipment for their data. So for now, they may be, if they're happy to host their data with us, we will, but with full respect for the data security, we would, even if it's hosted at MRC, we would make sure that the restriction on the data by the original owners of the data is respected. So become a member by being one of the nodes. And as a researcher, I also thought about maybe this would be the best steps for a researcher to join our platform. You register on the platform and create a researcher profile. Again, we are setting this up with different user profiles. So I'm just talking about the researcher here, but we are also coming on guidelines of people to join. So we explore, step 2 would be explore the medical imaging data catalog that we have. Submit formal data access requests if you see something that interests you through the Secure Data Access Manager, which then goes to the Data Access Committee. When access is approved, then you can access approved data sets and compute resources securely within the federated environment. Then, and final step would be develop, train, and validate AI model within the federated environment using our tools. So what would be our vision for the future and call to action? Then there are two simple things. We want to build a sustainable continent-wide imaging research infrastructure that would power Africa AI innovation in healthcare. We're starting with TB and pneumonia, but we're interested in all imaging modalities. So hopefully to extend, to grow to that. And AFRICAI-RI therefore envisions building this multi-country collaboration enabling impactful AI innovation in health research across the continent. How do you want to join? If you want to join, how do you get involved? For policymakers, patients, and citizens, you can make your voice heard in our stakeholder engagement activities. You would be undertaking stakeholder engagement activities where we hope stakeholders and policymakers, patients, and citizens who would be considered stakeholders will take part. For early career researchers and clinicians, access our training material ranging from federated learning, AI model development to clinical implementation and validation for hospitals and data centers. Contribute your data to the research infrastructure. It will stay private and secure while helping to train AI model for improved digital healthcare. We have a mailing list that you can join there. Maybe it is the image here. If you scan that, it will take you to this mailing list where you can join. If it doesn't work, I think the best is just use the mailing link there provided there. I think that was my last slide. Thank you. And any questions?
Thank you, Bubacarr. Thank you for this very nice and exhaustive talk. It was a complete talk, and congratulations.